Hi, welcome to lesson 1 for unit 3. Before we get started, I need you to go find, find a blank sheet of paper. I meant to put a blank sheet of paper at the start of your packet and I completely blew that. So pause the video, get a blank sheet of paper, and then we're ready to rock and roll. Okay, with your blank sheet of paper, I would like you to write down the following things, and eventually we'll get to that circle, that unit circle that's in your notes, as well as the chart. Okay, the things that are in your packet. Today's lesson is about something called radian measure. And you may remember that you have seen the word radian when you change the mode on your calculator. So far, we've used degrees. We've only used degrees to measure angles. And if you think about it, degrees are actually sort of a strange thing. They're not strange to us just because we're used to them. But 1 degree is actually defined to be 1/360th of a rotation. There's nothing really that normal about that. It might be more normal if we divided the circle into, into tenths or into hundredths or something. But why would we divide it into 360 parts? That is actually sort of awkward. So as strange as radians might seem to you now, understand that degrees really are strange and you're just used to them. So eventually you'll get used to radians and they'll seem normal as well. So you could write to yourself that radians are just another way to measure angles. An analogy that I make is that just like with length, you can measure in inches or centimeters or yards or meters. This is just a different measurement system. Okay, here I'd like you to draw a circle, and we're going to label that circle with radius 1. And I'm going to use my circle drawing tool because I'm not really that great at drawing things like circles. Okay, so we have a circle here. I'd like to move it. Thank you. Okay. And I would like you to denote that this circle has a radius of 1. So a radius goes from the center out to the edge, and that length is 1. Okay? In this circle with radius 1, we should write that down maybe. The length of the arc on the circle with radius 1 is actually what's called the radian measure of that angle. So what I mean by that is if you imagine an angle of rotation, so this line that we have right here, that's red, if we rotated from that starting point up some amount to get to a new location, and then we looked at this arc. Now imagine that the circle is made of wire. If you were able to take that chunk of green highlighted wire and straighten it out, that amount is what we call the radian measure of the angle I'm marking X. Okay, so I'm going to write that down, and then you do it as well, and we'll move on from there, okay? So the length of the arc on the circle with radius 1 is the radian measure of that angle. What I want you to take away from this statement is not so much the precise statement of it, but the idea that instead of measuring this angle, thinking about this part and thinking about the degree measure that that encompasses, when we're thinking about radians, we're thinking about arc length. Okay, so if you can associate the arc length with the idea of radians, that is good and powerful and helpful as we go down the road, okay? So let's take a look now and try to determine a conversion between radians and degrees, because we're comfortable with degrees, we know about degrees, and just like we can convert between centimeters and inches, we'd like to be able to convert between centimeters, or between radians and degrees, okay? So here is our circle again with radius 1, okay? And we know a formula for circumference. Recall from your geometry experience what circumference is. Circumference is going all the way around the circle, like walking around the circle like that. So the length of that yellow arc, that circle, if I were to be able to unbend the circle and measure it, that's what's called circumference. And the formula for circumference is 2 times pi times the radius, okay? Now, if we are using a radius of 1, then our circumference is just 2 times pi times 1, and the 1 doesn't really change anything, so this is just 2 pi. Now, how big is pi? What number is that? It's a decimal that goes on forever, but if we just estimated with it, we would say, well, circumference is approximately 2 times, now pi is about 3.14. That's why Pi Day is March 14th, okay? And so then the circumference, if I take 2 times 3.14, I get 6.28. Now remember we said radian measure is like the length of the arc in a circle with radius 1. Okay, so this would suggest that the radian measure of this circle, going all the way around, sorry, I'm just waiting for my writing to catch up. Radian measure of the entire circle is about 6.28 radians. Okay, now what's the degree measure of the whole circle? I hope you know that that's 360. Okay, so 360 degrees appears to be the same as 2 pi radians. Right? This number represents going all the way around the circle, a full revolution in degree world. And we just saw over here that going around the circle completely is 2 times pi in radian world. Now, to make this just a smidge more simple, because these numbers are kind of big, we could divide both sides of this equation by 2. So 360 divided by 2 would equal 2 pi divided by 2. These 2's would drop out. And we get the conversion that you will use a lot in this unit, which is at 180, that's 360 divided by 2, degrees is equal to pi radians. Okay, that's an important fact. Okay, that's like a conversion factor. All right, put a big star by that, that's big stuff. Okay? Now, using that idea, we are going to do a couple example problems, and then we'll get to that circle that's in your notes packet, okay? So the first problem I want to do is to convert 30 degrees to some amount of radians. Okay, now this connects very well with the unit conversion that we did in Unit 1. We're going to do some factor labeling. So we have 30 degrees. We don't want degrees, though. We want radians. So I want degrees to be kitty corner from degrees so they cancel out, radians up here. Now, you just wrote a very important conversion factor for us, right? Highlight it. It's that important, okay? This. That's the big stuff, okay? So we're going to take 180 degrees and switch it to pi radians. Oops, sorry. That was careless. Ah, I was on a regular pen, I thought. Okay, silly. Okay, so 180 degrees is equal to pi radians. That's a conversion factor, okay? And with this conversion factor in our problem, we're good to go, because now degrees cancels degrees. You could put this with a 1 underneath it if that helps you. And then you multiply fractions by going straight across the top and straight across the bottom. And now the 30 over 180, that reduces. 30 divides into 180 exactly 6 times. So this is 1 pi over 6, or sometimes we would, well, we typically would just say that as pi over 6. And the units that are left that aren't crossed out are radians. So we have pi over 6 radians. Now, to get a sense of what that really means, remember that pi is about 3.14. So this is just a smidge more than half a radian. So 30 degrees is just a little bit more than half a radian. Which one's bigger, a radian or a degree? I hope you said a radian, because it takes 30 degrees to make this angle, whereas it takes a little more than a half a radian to make that same angle. Okay, so radians have to be much, much larger. All right, that might be a test question. I kind of like that. Okay, let's get to our second example. Okay, convert 240 degrees to radians. Okay, I'd like you to pause the recording and try this, and then come back and see if you got it right, because it's really similar to the previous question. Okay, so I hope you tried the setup on your own and have an answer even. This is my setup. The degrees would cancel the degrees. I could put this with a 1. And some of you will like to reduce at this stage, and some of you will like to reduce at the end. It doesn't really matter much to me. I'm going to pretend I'd like to reduce at the end. So I'd have this as my answer. But I notice that both of these end in 0, so I'm going to divide out a 10. And then 24 over 18 certainly reduces. It reduces to 4 over 3. The pi is still there. Now, if you're not comfortable with reducing that fraction, you can use your calculator to help you, but I would rather that you get comfortable with it. But if you need a little check, like on homework, you could type in this, just the part that doesn't have the pi, and then use the math fraction reducing tool, and it would give you the 4 over 3. And then you just know that the pi is still there. The pi didn't get removed by what you were doing, okay? The next question we're going to do is our third example, and this is going to be it before we get to that circle in the chart at the end. This example is convert 5 pi over 4 radians to degrees. So if you compare this to the previous two problems, you'll notice that we're starting with radians this time. That's what makes this question a teeny bit different, and we want to end up in degrees. So really what that changes is our conversion factors setup right in here, okay, this part, the conversion factor. We want radians to cancel. We want to end up in degrees. So what's the conversion? 180 degrees is pi radians. Now check this out. This is pretty cool. The radians cancel the radians. Pi cancels pi. And we just have what you might call regular numbers. So we have 5 times 180 all over 4. And if we just do that arithmetic, we'd end up with 225. And the degrees are what's left, so that is what's going to go right here. Okay, the radians canceled out. All right, the next thing I'd like us to do is to take a look at that picture. And you'll notice in your packet there are several copies of this same picture. Oops, where did it go? Oh, give me a second. Okay, I'm back. Sorry, something disappeared on me there. I'm not really sure exactly what I did wrong, but here we go. These are the pages that I thought I had at the end of that. So this is in your handout several different times, and the reason it's in there several times is for you to practice. So a few problems ago, we did a conversion. Where was it? Here. We converted 30 degrees to radians, and so we found out 30 degrees was the same as pi radians. So on here, this is a picture of all of our famous angles, and so we could say 30 degrees is the same as pi over 6 radians, okay? Why don't we go through here and just at first, I'd like you to just put down all the angles. So for example, that's 30, that's 45, that's 60, okay? Come back in a minute, pause the recording, come back in a minute with all the degrees filled in. These are all the famous angles related to 30, 45, or 60. Okay, so take a minute and double check. This should be kind of standard. I don't know that we've necessarily filled in a whole picture like this before, but these are certainly numbers with which you should be acquainted. And from here, we are now going to fill in the different conversions, okay, the different angles that are equal to what we have here. Now, we've only done a couple like out by hand. We did 240 degrees in our examples, and that was 4 pi over 3. And we did 5 pi over 4 was converted to 225, so I know that this is 5 pi over 4. Okay, so a few hints here. All the things in the 30-degree angle, 30-degree family or the 30-degree bow tie have 6s on the bottom. So that would be these guys, okay? The one to the right is 1 pi over 6. This is 5 pi over 6. This is 7 pi over 6. And this one over here is 11 pi over 6. Now, you can get these by actually doing the conversion like we did in the examples. I'm just telling you because I happen to have it memorized, as you will very soon, okay? The 45-degree family has 4s on the bottom. So this one we did over here already is 5 pi over 4, and then this one, okay? And if you start over here, this is 1 pi over 4, 3 pi over 4, 5 pi over 4 we already talked about, and 7 pi over 4. So notice those were all odds, 1, 3, 5, 7. Okay, the ones that are in the 60-degree family all have a 3 on the bottom. We already did this one, and the 3 over here, okay? Now the one in the first quadrant is 1 pi over 3. This is 2 pi over 3. 3 pi over 3, if you think about it, the 3's would cancel. That's just pi. We know that pi radians is 180 degrees. That's the conversion we use. This is, so going back, this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3 we'd already done, and this would be 5 pi over 3. Okay, and now we just have some quadrantal angles left. If 180 degrees is pi, 90 is half of that, so half of pi. And down here we have 1.5 pi, which is 3 pi over 2. 3 over 2 is 1.5. And if you come over here to the right, all the way around the circle, we already discussed in the notes, is 2 pi radians. Or if we haven't revolved at all, it's 0. So this, and this are two different representations depending on whether you're saying I didn't rotate at all or I rotated all the way around. Okay, so I need you guys to get really familiar with the degree measures as well as the radian measures. And so there's several copies there just for you to fill in and practice. If you have a better time filling in or practicing off of a table, you certainly can do that. I've included a blank table here, and you could write in all of the measures from that unit circle right here. Okay, so if you would rather, you could try to memorize it this way. I personally think it's easier to memorize in the circle because there are patterns that you can see, and there are even more patterns coming up that I think are easier to see in the circle. But I know for some of you this might be useful. I'm going to pause the recording and fill in the table, and then I'll come back and just show it so you can see what the table should look like. But that's all that you need to do for today. Okay, so thank you so much for watching this video and taking notes. I'll see you in class. Okay, so if you are still with me, you can look at the chart. I'll just scroll through it. I highlighted the quadrantal angles. Okay, I'm going to scroll back up and just go through it one more time just in case you need it. Okay, notice those colors there, green and yellow. Go Pack!